Hello, in this video we're going to discuss the radians of these special angles. But before we do that, what is a radian? Well, I'm going to illustrate a radian in the picture below. The radian, one radian, notice it says one radian here, is the measure of this particular angle where the radius of this particular circle and this arc length are equal. Notice how it says arc length equal to one radius. So if I take this distance like a string and I wrap it around to get this distance right here, the measure of this angle, where this radius and radian arc length are equal, it will be 1 radian. And it doesn't really matter what size the circle is, you would still get the same measure of that angle. For instance, if you look at this small circle, even the smallest circle right here, and you take that radius, right, equaling to this arc length, you get the same measure of that angle. So what I'm going to do now is I'm going to break this up into, go around 1 radian for each and see how many radians is around one circle, one whole circle. So maybe that would be another radian. And maybe here, does that approximately look like another radian? So if you notice, if I start with half the circle, right, half the circle we know is 180 degrees. So let's write that down. 180 degrees is half of the measure of half the circle. There is 3 and a little bit. So we have 1 radian, 2 radian, 3 and a little bit. In fact, the exact answer, that's where they've gotten the pi from, is pi, which really makes sense because pi is about 3.14, 3 and a little bit. So that little bit there is the decimal places of pi, 1.4, right? It goes on 159, whatnot. So that's where pi comes from as well. So we know that this is pi, and then that means all the way around would be 2 pi, or 0 degrees, which everyone, or 0 radians. You can even do that in radians. Doesn't erase well. And that is going to bring me to my picture below. So let's scroll down and look at the unit circle. So that makes sense here. You can see that 180 degrees is pi, right? 2 pi is either 0 or 360 degrees, or 0 or 2 pi. So let's look at some of our special angles. The first one I want to look at, let's rewrite that. Pi is equal to 180 degrees first. The first one I want to look at is 45 degrees. So we learned that to convert from degrees to radians, I'm going to use this conversion factor. So I'm going to multiply by pi over 180 degrees. And that makes sense because if I put this over 1, we want to get rid of degrees, so that's why I'm dividing by degrees, and bring on radians, bring on pi. So that would be, if you notice, if you cancel this, this will go in once. 180 goes into 45 goes into 180 4 times. So you can see that's where the pi over 4 comes from. This also makes sense because the whole half was pi. Half of that is pi over 2, which is 90 degrees. Half of that is pi over 4. So this distance, half of the quadrant, is pi over 4. Which brings me to my next picture. Let me scroll down. Here's an empty unit circle. So let's rewrite what we said. This is pi, right? This one right here, we just learned was pi over 4. Makes sense because half of pi is pi over 2. Half of that is pi over 4, which we saw was 45 degrees. So there is another method to finding these radians. I like to visualize this by counting. So if I think of pi and I break it up into 4s, that would mean I break up my top quadrant into 4 pieces, and I would get 1 pi over 4. This would be 2 pi over 4, 3 pi over 4, and this equals 4 pi over 4. And you can see that this reduces to pi over 2 and this one reduces to pi. So you can kind of find these by counting without even ever converting at all. So this one would be what? 5 pi. We're just, right, counting along. The next one would be 6 pi over 4, which, by the way, does reduce to 3 pi over 2. What's the next one? We're at 6, so we're at 7 pi over 4. And then finally, we're going to land at 8 pi over 4. Then draw lines here. 8 pi over 4, which we know is 2 pi. So that is breaking up. So if we look at the neat picture, there's, right, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, finally 8 pi over 4, which is 2 pi. You can do that with the 60 degrees. Let's do that with 60 degrees. So first let's convert this like we did before. So that would be multiplied by pi over 180. And 60 goes into 180 3 times. So now we're looking at pi over 3. We're going to break pi into 3s. So let's do that in the empty picture below. Oh, I got to erase. So we say 60 degrees, right? This was pi. And 60 degrees was pi over 3. So we're going to break this up into 3s. 1. What do we get? 2. Oops. I keep it right here. Sorry about that. You get this. So that's breaking it into 3 equal pieces. 60, another 30 plus 30, 60, 60. So that would be pi over 3, which we just saw was 60 degrees. So this would be 2 pi over 3, 3 pi over 3, which we know is pi. Okay, here, this is a little tricky. We have to go like this. All right. These all look the same. So the next one we're at 3, so 4 pi over 3, 5 pi over 3, and finally 6 pi over 3, which we know reduces to 2 pi. So that would be 60 degrees. Again, if we look at the nice clean picture, right? 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, and 6 pi over 3. Those are the ones that you need to memorize. Last one, let's do 30 degrees. 30 degrees we know is pi over 180. There's going to be some overlap with 60s. That cancels with that, since you get a 6. Right? 30 into 180 is 6, so we get pi over 6, which we see is 30 degrees in quadrant. To get the rest, we could do all the same way, or we could just start counting. So let's do that in the picture below. The reason I said there was going to be some overlap, if I do it in a different color, right, this would be 30 degrees. So we would take pi and we divide it by 6. So there would be pi over 6, which is 30 degrees. So this would be pi over 6. Break this up into 6 pieces, right? So there would be the 6, red and blue combined, and this would be a 1 pi over 6, 2 pi over 6, 3 pi over 6, forgot that one, 4 pi over 6, 5 pi over 6, and 6 pi over 6 in blue. And you can see that 2 pi over 3 does reduce to pi over 3, right? 4 pi over 6 does reduce to 2 pi over 3. 2 pi over 6, I don't know if I said that right, reduces to pi over 3, and so forth. You can do this below, break this up into 6 pieces, and you get 7 pi over 6, 8 pi over 6, 9 pi over 6. The next one is 10 pi over 6, 11 pi over 6, and 12 pi over 6, which we know is 2 pi. So you can do it that way as well, and you can see that the 5 pi over 3 and the 10 pi over 6 do reduce to each other, and the same with the 4 pi over 3. Very sloppy, I realize, but if you look at the neat picture, it does work. Let's look at the pi over 6. Pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi, oops, what happened? 11 pi over 6, there it is, 11 pi over 6, and finally 12 pi over 6. So that is another way for you to memorize radians. Hope that helps.